Rightio, so I messed that up there. I'm still getting used to the way to do this, so part 2 is going to be much shorter than I intended. Part 3 is going to carry on, and I'll just pick up where I just left off. So we'll switch the camera back around. I'll zoom in a little and go back to Carl, who was saying that the distance between LA to New York City is about 2,800 miles. We went through that. Strongest tailwind ever recorded could not push an airliner fast enough to make a 12,000-mile journey in under 13 hours. Well, I heavily disagree with that. The actual distance is 6,135 nautical miles, and the distance and the initial course from Sydney is southeast. So again, as we saw in part 1, how the maps distort the lines that way in the north, here to do it for the south, they distort it that way and say that that's the flight route going directly beneath New Zealand. Now, I'm not a pilot, so of course I'm not qualified to comment too much about that, but see if we can. They put a lot of gobbledygook in there. Yeah, it's got to be all sort of trade industry standards so that the average person can't understand it too well. Eddie says the Earth is still round, and I used to be one of the guys assisting with those LASIK procedures. Get with the times, Renob. Yeah, lovely fella. That's why I don't give him too much attention, because, you know, what the hell's a Renob? Carl Becker. I plot and use jet streams every time I fly. So here he's now saying he does use it. So things that go 200 to 300 miles faster than the rotation of the Earth. So when you put those speeds together, you know, you were talking, let's just say the average of 1,000 miles per hour, which is the equatorial spin, plus another 300 miles per hour. Even if we removed the extra rate that would go because you're further south or north, in this case south. So the rotation of the Earth has dropped by 300 miles per hour. That combined with the jet streams still makes it 1,000 miles per hour. And then you add that to the speed of the plane, going 500 miles per hour, then you're going 1,500 miles per hour. So you could certainly travel that distance in the time that you were saying, whether or not the ground beneath was moving. All you have to do is otherwise say, well, it's just the speed of the plane plus the jet streams is still going to go approximately 1,000 miles per hour, whichever way you look at it. Here's the next. Do that again. Last time I hit the back button, not the switch button. I'm scrolling. I have to scroll this one. Far out. Here's an explanation how jet streams are formed and how aircraft compensate for the curvature and rotation of the Earth. Rotation correction. We use the west-east jet streams to help cover distance along the Earth more quickly. We plot them and plan routes within them to give us a tailwind, or we avoid them if they are going opposite our route of flight. Jet streams are created due to the temperature difference between the equator and poles. You must know that warm air rises if you've ever seen smoke rise from a fire, and you know cool air descends if you've been the mist. See, this is what shits me about gloves, is that they assume, as a flat earther, I haven't discussed this stuff for decades. I know how a hot air balloon works because the hot air inside the balloon is less dense than the surrounding cold air, and it's sufficient enough to lift an entire basket full of people up into the air. So yes, density and buoyancy due to temperature, and which determines the density, is absolutely something I'm entirely aware about, and I find this a little bit condescending, but you know, these are these people who think they're intelligent, think they're talking to a child. They're always going to be condescending. So anyway, cold air descends at the poles, rightio, and starts to spread out laterally on the Earth's surface. This sets up a conveyor belt effect between the poles and the equator. However, the Earth is rotating. Well, yes, it would rotate beneath that, which will just create southerly winds in the south and northerly winds in the north, but it wouldn't explain jet streams. But let's not do that. Bloody hell. This is going to take me a while to get used to. sets up a conveyor belt effect between the poles and equator. However, the Earth is rotating. With any rotating object, there is a force called the Coriolis effect. Imagine rolling a marble to someone on a carousel that you were both... Oh, God. He really is condescending here, and it's frustrating because we flat earthers were the ones pointing this shit out to you guys ages ago. You know, we've been doing this for so long, and we show that if you do that, the marble moves because the ground beneath it is moving, but it moves sideways like those people on that, what is it, on the carousel just throwing a ball backwards and forwards to one another. The ball itself actually stays moving straight. However, as you'll see, constantly he will ignore the fact that I keep bringing up orbital speed. And that is really, really important. So this can also be explained by the conservation of momentum law. So he's already calling it a law. And this also gets to me. The same thing happens to winds, and they blow south to north in the upper atmosphere of the northern hemisphere. Oh, the upper atmosphere, okay, yeah, because the lower ones are going north and south. That's fair enough. Of our rotating Earth. It's opposite in the southern hemisphere. They curve around and create west to east jet streams of wind at high altitudes. This effect also explains why the prevailing weather comes from the west in places like the Pacific Northwest of the United States and the United Kingdoms, and comes from the east in places like the Caribbean and Florida and the Philippines. Well, no, they're all north of the equator. Prevailing weather comes from the west. No, that doesn't actually explain anything whatsoever. Anyway, these winds and weather patterns prove a rotating and spherical Earth that cannot be explained on a flat Earth. Because we compensate our courses based on the movement of winds, we compensate for the Coriolis effect automatically. Okay, so because I said I was going to make this thorough, I just had to change my chair a bit. The other one was getting a bit uncomfortable. We can explain this on the stationary planar Earth quite simply. I don't think you can zoom on this method, no, this mode. Bugger. Bring it a bit closer, I guess. Bring it a bit higher. We can explain that because on the stationary planar Earth, the sun is constantly going around the equator and it travels from the east to the west. So it's not because the Earth is spinning like a space ball. And in the wake of that path of that sun, what we're experiencing is vortices of air spiraling off in opposite directions, just like you see in the wake of a boat. So it's not like you're necessarily needing the temperature to explain why the winds are going that way. I have to think for a second. There's a lot going on in my head. That the sun, of course, produces the light, which produces the heat. The heat itself does not come from the sun, but because the light comes from the sun, and technically we just automatically accept and think that the sun is hot, but it's not. The heat is actually produced down on the ground. And so because the heat produced on the ground is also travelling in that direction, clockwise, from the east to the west, that creates the prevailing wind currents, and they spiral off. They do not just go all the way around to the poles, as you think, like a big torus field, even though a lot of people do describe it like a torus field, and that does also match expectations and observations. It's still small butterfly dynamic effects that sometimes one of them will hit the right temperature and humidity, and that little vortice will turn into a giant hurricane or something. But that's not describing the trade winds whatsoever. But on the stationary planar Earth that works, you look at the maps as I've showed you earlier, as we've all seen, they move relative to the position of the sun, which the flat earth absolutely does explain. Okay, so his next one, he goes into curvature correction and says the nose of the airplane is pitched up between 2 to 3 degrees at our cruising flight level to create the lift required to maintain those high altitudes. By maintaining a constant pressure altitude, we follow the curvature of the Earth. I'll explain further. On the heads-up display, the HUD of the Boeing 787 below, you can see level flight represented by the long horizontal green line. This line is called the artificial horizon. The pitch bar is the thick, shorter line above the artificial horizon. Sorry, I've lost it. I was chasing a fruit fly. Above the artificial horizon. You can see the aircraft is pitched nose up about 3 degrees. The difference between these lines is called the angle of attack. This is the angle required of the airflow on the wing to generate the lift needed to counter the force of gravity on the aircraft, thus you maintain level flight. In this case, flight level 380. Huh? That doesn't make a lot of sense. Nearly got that little bugger. You can see this in the altitude window on the right side of the display. Flight level is an altitude in feet corrected for standard atmospheric pressure, but that's another discussion. I agree. Now, on this HUD, you can see the actual horizon is about 2 degrees below level flight. Why? The Earth is curving away and down from the nose of the airplane. So I will address that, believe me. In fact, let's just have a quick look at the image so I can address it straight away. Because this is where they start to get dishonest or simply just disingenuous. You know, he's not deliberately dishonest, but what he's failing to realise, yeah, that's the horizon, but he's already admitted that the angle of the nose is pitched up 3 degrees and it's shown 3 degrees of pitch, and he's calling it dip to the horizon. But not only that, as we know on the stationary planar Earth, the horizon always rises to eye level. So when you're at great elevation above the ground, then a lot of what would ordinarily be ground horizon is now atmosphere. But that atmosphere itself is still ramping up to eye level. So that's what he's disingenuously not even recognising, both the fact that the horizon is ramping up to eye level and the fact that a lot of that horizon is now atmosphere. And so, of course, that will also give you the so-called dip. So, sorry, I went through that a bit quick so I could look at that picture. So, why? The Earth is curving away. He's literally saying the angle of the nose is curved up or pointed up 2 degrees, and now the actual horizon is about 2 degrees below. So, how do you want it, mate? Both ways? You don't get it. If you're angled up, then yeah, it's going to appear below that. If you have your camera perfectly level, as it would be on a plane if it was perfectly level, then it will be at eye level. I don't know what he means by FL380. Maybe that's a pilot's term, obviously, because they like to use some technical terms to make themselves look smarter, because sometimes by outwitting people and saying, look how much I know, you can't prove me wrong, because at FL380, the actual horizon is about 150 nautical miles away. At a speed of 600 nautical miles per hour, it will take about 15 minutes for this 787 to reach a point above that horizon. Well, yeah, that's pretty much what it should be doing. And when a little math will tell us that's about 1 degree of curvature followed every 75 nautical miles, 8-ish minutes of travel or so. And again, they don't get it. But anyway, it becomes clear. I'm just going to go through the comments before I even... Oops, nearly hit the wrong one. That amount of curvature correction is imperceptible on instruments or felt by the passengers. Another unit of measure would be the 8 inches of drop per nautical mile. It's about well, no, it's not nautical mile either. They're, again, disingenuous, but we can understand human error. This is about the length of your hand in altitude change over a mile. So even at 600 miles per hour, that amount of drop is again imperceptible in instruments or felt by the passengers. So, wait, what? The nose of the plane is angled up 3 degrees, but the HUD only shows 2 degrees of drop. The Earth can't be flat, it must be concave. It's not being a smartass, because it's literally the saying. I appreciate the length response, and we'll get back to this later, because, I only get short breaks when I'm at work, so I've got to do this on my breaks or when I get home. First thing in the morning is usually when I start. Please tag me again if I lose this thread. Also, just quickly, if 1 degree is 69.4 statute miles, why is the horizon 2 times lower than that, but really only 3 millimetres in visual space? See, somebody had to give that a laugh emoji, didn't they? Because they don't get it. If a degree is 69 miles or 60 nautical miles, then the horizon should be 120 miles beneath the HUD if it's 2 degrees of drop. But they keep swapping around their arguments all the time. That's how they do it. Face the camera and say that. That's how they do it all the time. Is they'll jump between degrees, RPMs, nautical miles or statute miles, doesn't really matter too much. But if 1 degree is 69.4 nautical miles or 69.4 statute miles or 60 nautical miles, and he says that the horizon has dropped by 2 degrees, why does it look 2 millimetres and not 120 miles? They can't explain that. That's why they have to do a laugh emoji, because you triggered them. The aircraft is pitched 3 degrees nose high, to create an angle of attack. Because once you put it into an abbreviation, it's more official. On the wing, which produces enough lift to counter the force of gravity at cruise altitude. Angle of attack is defined as the angle between the flight path and the mean aerodynamic chord of the wing. Think of it as the angle you hold your hand out the car window to feel an upward force. Your arm to feel an upward force on your arm. The pitch bar, thick, short green line shows this angle. The flight path is shown. He sees typos. To me, that's an indication too. Not necessarily of intelligence, but just level of care. If you really care, you go back and fix your typos so they don't look stupid when you read through after you've sent it and you proofread it. The flight path? What's a flight path? But anyway, is shown by the circle in the middle and on, the artificial horizon, which is the long thin line. This shows the airplane is flying level at 38,000 feet. Well, that's one thing we can agree on. It's flying level. Thank you very much. The actual horizon is showing 2 degrees below level because Earth is curving down and away from the nose of the airplane. Wrong. That is showing elevation, that you are at 38,000 feet. And that's what beneath you, ramping up to eye level, is mostly air. So, of course, the horizon will appear slightly lower. Because Earth curves at 1 degree of its circumstance every 69-inch miles, I'm pretty sure he meant circumference, but again, he might have been having a few red wines or bongs or whatever, but, I don't know what pilots get up to in their spare time, but he's obviously off his chops. That means that horizon is about 150 miles away. No, it should be 150 miles beneath you, not in the distance. 150 miles away, and you consider how many miles you are flying per hour, it makes no sense. It makes no sense. I don't get what he's talking about. You're doing more than 150 miles in an hour. It will take 15 miles at 600 miles per hour. Holy crap. Obviously, he can't tell the difference between minutes and miles. So he's obviously not the greatest pilot for me to be referencing to try and prove this worldly revelation that we live on a flat Earth, because he can't even say, 15 miles at 600 miles per hour. It should say it will take 15 minutes at 600 miles per hour to get to a point over that horizon, in which case I'd say maybe he's onto something. Erland Hovde decides to jump in here and lend a hand. Says to Ross Thatcher, who happens to be me, Iron Horse, if the Gleason map is the correct map for the Earth, if the Gleason map is the correct map for the Earth, why is there a multitude of projections available? There would be no need for different 2D representations of the world when there's one that's correct. And so, of course, I'm having a conversation here with Carl Becker. And so I recently made a video describing this angle of nose up, which kind of works for either model. And I will put this up for just a brief moment so you can see where I did it. I'll unmute it.
Well, good day. This is Iron Horse here, and welcome to my channel.
So there's my channel.
Here I discuss
Iron Horse.
everything
Do planes need to nose down? So I'm not going to waste time on that because you can find the link. That's the link written right there. And we can move on because I then said to Erland Hovde, they all look basically the same, even the incomplete ones. And so if we have a closer look at some of these, see, these are all different maps that sailors followed the constellations, which has never changed for thousands of years. So let's have a quick look at some of their maps. Exactly the same. Incomplete, but very, very similar. Tells you how far in time we go. That one also only shows the west coast of Australia, which is actually Olimoroa. Cook's route charted the east coast of Olimoroa and called it New South Wales, when it was previously known as New Holland for 200 years, so he didn't discover Australia. Magellan's route is sort of mapped out on a slightly more modern version. This one here is a classic where it just shows Australia as basically a big blob. So we've had these maps for thousands of years. It's not just something new, despite what the glyphs will say. And he goes, not all the same, and then he shows a whole heap of different globe projections, and it's like, well, hang on a sec, they're not our maps, mate. They are your globe projections. Whereas the question was, if we look back again, his question was, if the Gleason map is the correct map for the Earth, why is there a multitude of projections available? Because they want to twist the Earth into a globe. So they have to do all these weird and wonderful nonsense bits of crap, and none of them are really a representation of reality whatsoever. So that's why we often do say that you've got to lie to glyph. So Carl Becker comes back responding to me, if that's you in the video, you are fairly intelligent. You have many of the concepts correct, such as air pressure, thermal exchange, and aerodynamic maximum altitude. You have the angle of attack pitch correct, but not the reason for it. The airplane doesn't porpoise because of lack of angle of attack. Angle of attack is strictly needed to produce the lift required to counter gravity. Thrust also has nothing to do directly with lift. Thrust produces the forward motion that provides airflow. The pitch produces lift. Well, I did try and simplify it and say basically that without thrust, you don't get no pitch, therefore no lift. So even though you've got different technical terms for every little different thing, without thrust, you got no pitch, you got no lift. So thrust has everything to do directly with lift. Fugoids, hang on a sec, wrong phone again. Or porpoising is due to aircraft longitudinal stability. That discussion involves centre of gravity versus centre of lift. So I guess that means centre. That discussion involves centre of gravity versus centre of lift, positioning, and many other aerodynamic factors. So in other words, got to lie to glyph. Is that a thing on that screen? I think it might be. Aircraft longitudinal stability. I mean, even if you sat and thought about that for 10 minutes, longitudinal stability. It's got nothing to do with the longitude. You could be flying latitudinally, longitudinally. So it's sort of like making up terms. And then he has to bring up centre of gravity versus centre of lift, positioning, and many other aerodynamic factors, whereas I just simply simplified it by saying that the position of the wings in the aircraft and their angle that they're produced at, so that the angle of the aircraft flying at 3 degrees stops it from porpoising. So he's trying to just go a long way around to say, yeah, you are correct, but I know more about this because I'm a pilot. You don't know. You're just a flurf who's never flown a plane. So just trying to complicate things unnecessarily. Now, you've seen airplanes land. They end descending towards them. See, these typos are frustrating. They are descending towards the runway with the nose up 2 to 3 degrees. This alone shows you don't. So they're up, what? 60 nautical miles times 2 or 3? See what I mean? How can you say degrees when you've already admitted that 1 degree is 69.4 miles? How can a nose of a plane be up 69.4 miles? It makes no sense. Well, this is what they do. They just keep chopping and changing and saying, well, this is 1 degree and 1 degree is tiny, but 1 degree is 69 miles. But this alone shows you don't need to nose down to follow the Earth's curvature. No, it doesn't. It shows that when you produce less thrust, the plane slowly drops and descends, and as long as you continue thrusting forward, you can continue having the nose pointing upwards, and you will fall towards the stationary plane of Earth. You would never do that over the amount of drop that is required for the globe, which we all get to because there's mess here, and I keep hitting the wrong phone. So just by maintaining a constant pressure altitude, we are following Earth's curvature. No, you're not. You are not. You're just dropping from height back to the ground. As you said, it's 8 inches of drop over 1 mile. That is absolutely nothing. On approach, we're dropping hundreds of feet every mile with a nose-up attitude. You can see that watching airliners at any airport. As a passenger, you don't feel much of a difference between cruise speed and approach if the air is smooth. Well, again, that's a little bit like being on an elevator, is you don't really feel very much because you're on a flat surface and it's not moving over a curve or relative to any other surface. It's sort of coming in only angled up 2 to 3 degrees, which is barely noticeable on the plane, and you're dropping with it. So it's not even like a vomit comet where you're free falling through the air. You're actually falling stuck in your seat, probably with your seatbelt on at this point. And of course you're not going to feel anything because everything is moving. That is what relative motion means. Everything is moving as one body and you're in that body, but it doesn't mean anything about the Earth itself moving. Okay. As a passenger, you don't feel much of a difference between cruise speed and approach if the air is smooth. No shit, Sherlock. As far as astronautics and orbital mechanics, you don't need atmosphere to steer, brake, or enter orbit. Thrusters and gravitational pull are all you need to manoeuvre and navigate in space. So he's responding to something here that I feel I've already said. I did. I said it in that video. So this is actually a response to my video. So I have said that you do need to have atmosphere to steer, brake, and so forth. Because without it, without friction, there's no slowing down, there's no stopping, there's no steering. You are just at the mercy of whatever speed you left into the void with, and that's what you'll be stuck with forevermore. Nearly hit the wrong phone again. Thrusters and gravitational pull are all you need to manoeuvre and navigate in space. Well, that's, okay, I might slightly accept gravitational pull if I believed in it, but I think it's absolute nonsense. There's no such thing as gravity. It's all made up nonsense, which they've had to invent to make space flight seem feasible, and that the fact we went to the moon, like how could you slow down heading towards the moon with nothing to thrust against except the moon itself? You'd basically be flying a rocket at 20,000 or whatever plus miles per hour through the void with nothing to slow you down, nothing to parachute against, nothing whatsoever. And you'd have to sort of slingshot around it with your gravity several times to try and slow down, but you'd pretty much then have to turn around and thrust your ass off against the moon to stop from crashing into it. And plus, it's also rotating on its own axis at 10 miles per hour, let alone 2,280 miles per hour to orbit the Earth, which, unfortunately for you gloves and people that believe we went to the moon, you can't even land a drone on a treadmill going 10 miles per hour. Land a drone safely on it. But the drone has the benefit of thrusting against air with its little wings. That's what it does, its little rotors. There's no such thing on the moon, let alone Mars and all the rest too that we've... I don't want to go down that path at this stage, but I'm just saying that if you try to land without the benefit of an atmosphere moving with the ground beneath you onto something moving even just 10 miles per hour, you'll get torn to shreds. Absolutely torn to shreds. Oh, there we go again, wrong phone. Look, if that is you in the video, you seem like a nice, intelligent guy. Well, I appreciate that. I'll be happy to discuss aeronautical and astronautical proofs of a rotating spherical Earth anytime. Not only am I an international airline pilot, having flown 747s and 777s, but I also have degrees on aeronautics and astronautics. I guess that's another typo that auto-corrected from in. So aeronautics and astronautics. So he's got some nice big words and credentials, and this is how pilots work. They're all ego. So I respond back to him, yes, that's me, and I've been doing many debates for many years and working on complex solutions that match observations on the stationary planet Earth. As an aeronautics guy, you should know better than anyone that the Earth is flat and stationary. Pitch would be useless without thrust. I'm simply demonstrating in simple layman's terms, but I'm sure you highly trained experts... Come on, get it right. I'm sure you highly trained experts would run rings around me in your specialised fields when it comes to the technical terms, but education and training doesn't necessarily always imply greater intelligence. Logical deduction doesn't require profound technical knowledge, though some amount obviously helps. I'm still sure that part of the slowing process requires less thrust. Oh, this is to do with the planes because I didn't copy and paste every little thing, so responding to dropping via the plane requires less thrust, which allows for dropping due to natural buoyancy factors, even if you are still caught in the gravity trap. And he totally misinterpreted that, because I'm not saying that the plane is buoyant. I'm saying that it is given lift, which is buoyancy, due to thrust and due to air motion. So it's artificially creating buoyancy, which is how a plane flies. So yeah, it is technically the wrong term for it, but it's also absolutely the correct term for it, because you've forced yourself through thrust to be buoyant. So it's unlike the hot air balloon, which does it through density, so it does it much more naturally and quietly and efficiently by thrusting the aeroplane through. It is a buoyancy thing. Again, the 8 inches mile seems insignificant, but it becomes highly significant at speed. That's the problem. 600 miles per hour is 10 miles a minute, and because it's not a slope, it's 10 miles squared times 8 inches, and 800 divided by 12 equals 66.667 feet per minute of drop, just to follow the curve. If you subsequently calculated it for that, calculated it for the entire hour, moving 600 miles, the drop becomes 600 by 600 by 8 equals 2,280,000 inches, divided by 12 is 240,000 feet. Let's say your altitude remains 35,000 feet. That means you're dropping in 1 hour almost 7 times your cruising altitude, all while nosing up 3 degrees. Surely you must realise the absurdity of that. 45.5 miles or 91 Burj Khalifas of drop an hour. The faster you go, the greater the rate of drop. I simply refuse to accept that any person intelligent enough to be trained how to fly so much as a Cessna would genuinely accept and believe they're allowing for such a huge rate of constant drop. On the surface, as I explained in my video, it seems reasonable enough to be falling at the correct rate of thrusting or pitching to maintain the cruising altitude, but the maths don't lie. They're staying level because they're flying level, and you must know it, just seem to be afraid to accept it. Carl Becker. And I didn't really click on him before, did I? Yeah, I'm not going to expose him too much. That's his name, that's his profile. He's locked his profile now, so I don't blame him because he heard he's having a video made about him. He says it's great, nice to meet you. First, and your biggest mistake is the 8 inches squared does not apply if you drop the 8 inches for every mile you travel. It's just dropping 8 inches every mile. As we travel forward every mile, we drop 8 inches every mile. 1 mile forward, 8 inches a drop. Another mile forward, 8 inches a drop, and so on and so forth. The squared does not apply. And 8 inches squared isn't the correct formula for Earth's curvature anyway. That would graph a parabola y equals x squared. I'll attach the correct formula and explanations below. It's not like we go forward 1 mile and then drop 8 inches either. We follow an extremely shallow arc through the sky. The same arc as Earth's curvature because we maintain a constant pressure altitude above Earth. When we start a descent from cruise altitude, the flight path arc is much, much steeper and you still don't spill your drink. Again, the whole elevator drop function. You're falling at the same angle and you're right. What about my right? Is it anything like my left? I think he means you are right. Education and training do not always equal intelligence. Yes, see, I'm also an English major, amongst many other things. Not that I necessarily majored in it, but I am an English major and typos stand out like dog's balls to me. So, yep. English is important because that's actually how we communicate too. So little things tell me a lot. The fact you don't go back and correct them also tells me a lot. But anyway, it is what it is. Education and training do not always equal intelligence. However, in my case, they absolutely do. See, this is how it unfolds. Pilots are full of themselves. Because I actually navigate the Earth for a living in aircraft. My education can explain my observations, and my observations confirm my education. They work harmoniously together and greatly improve my... No, I just hit the wrong fucking button. Aerodynamics, weather effects, and global navigation are things I've learned extensively about and use every day as I've planned, so I can be the most effective airline pilot possible. See, I'm sorry to be reading it in sarcasm, but this is his ego speaking. Pitch is absolutely not useless without thrust. It absolutely is. You could flap your wings up and down all day standing on the airport tarmac, but you ain't going nowhere without thrust. Look at a glider, no thrust, but pitch is extremely important. Well, that's not true at all. The glider is still thrusting. It's basically literally doing what they say satellites do. It's dropping at free fall speed, but then because of the shape of its wings and its pitch and all the rest and its motion, it falls without missing, or falls and constantly misses the ground, which is actually what Hitchhiker's Guide to the Galaxy, Douglas Adams, said. Falling is, you have to throw yourself at the ground but miss. you orbit. That's pretty much what a glider is doing, is gaining sufficient thrust. And I do address that, so I'll shut up. I'll just keep reading. Oh, no, not that camera, you idiot. I'll get it eventually. I'm not sure how you think buoyancy figures into aerodynamics and aircraft stays aloft due to lift, countering gravity, which is exactly what buoyancy sort of is in a sense, only he's even spelling buoyancy like a child. If it was just about buoyancy, wings would be irrelevant. Well, it's not just about buoyancy. You gain buoyancy by having wings and thrust and lift and pitch. It's almost frustrating because he doesn't get where I'm coming from. I'm already 5 steps freaking ahead of him and he doesn't seem to realise it. So you can see it's not that the math is lying, it's that you are applying incorrect math while also not having understanding of the big picture. Now it is you that's probably afraid to accept it. Sorry to burst your flat earth bubble with a sphere. And then he shows this weird thing. I will open it up. Why not? Give him some... I'll just zoom in on this one. Working with the spherical Earth. I apologise right now for the horrendous amount of geometry involved in this post. Yeah, see, they have to make it complicated. They just have to. You can read that if you find this thread. This is 6 days ago, as you can see. So this thread, which Facebook wouldn't let me find all these comments to, will show up on my phone. So I've said, yeah, well, nice to meet you, and hopefully we can keep this discussion cordial. You'll have to forgive my abruptness at times. Years of heated exchanges, defence and being attacked have honed me into a bit of a heartless attacker at times, and I'm prone to overreact. You don't seem like the overtly aggressive due to ignorance kind, and you've honourably admitted that I'm no intellectual slouch. So I'll try to remember my manners. Laugh out loud. I've tried many times wrapping my head around this 8 inches per each mile travelled, and I can only conclude that it represents a slope, not a curve. It's the speed travelled that determines the rate of drop, so even at 10 miles a minute, an 80-inch drop is still steady decline, but over a curve it's still 46 feet, which if you do work it out minute per minute, it's not even quite that 66 I've worked out before. The 8 inches a mile squared is in fact extremely accurate, and it must exist in every place in every direction. Adding topography only increases the rate of drop, as measurements are generally referring to as above mean sea level. I believe this is why places like the Alps and the Andes are avoided for most flight routes, as air pressure for altitude measurements isn't always 100% reliable. However, as long as everyone abides by the same standards, it's sufficient enough to avoid collisions amongst yourselves. Of course, it's not a complete formula for the entire globe fantasy, but for all relevant distances fitting within the range of human visibility, it's accurate enough. I'll drop a link below showing exactly why. The problem you face is you are now contradicting thousands of other pilots who've stepped forth to admit that they don't ever account for curvature. There's even a retired Polish astronaut who openly admitted that the Earth is flat. I believe they call them cosmonauts, but either way, ending phonetically in naught describes exactly how many times we've been to space. The constant pressure, altitude and video footage of the constant pressure, altitude. Did I make a typo? Damn it. Constant pressure, altitude and video footage of the SR-71 flying perfectly flat and level all comport with the expectations of a flat Earth and make a mockery of the globe belief. The drink will never spill, even in a Vomit Comet 0G simulation, because all things in air, especially encapsulated pressurised air, drop at the same rate. So long as the water remains in a container, it won't spill out. Even more incredible is watching stunt pilots performing a barrel roll while pouring water from a bottle into a cup. G-forces, or centripetal forces, balance out in a way that seems to defy physics, but not really that different from when we spin a bucket of water outside in an upright circle. So long as you don't suddenly stop, the water follows the downward or outward force, which suggests that if we are living on a globe, we're actually living inside of it, being pushed outwards, not inwards. However, then there's the problem of the apparent sunset. It works on the stationary planar Earth due to perspective, but cannot work the way we see on either the globe or concave Earth model. Trust me, I've spent decades contemplating all theories, and the one which agrees with my years and years of observations always confirms the stationary planar Earth model with topography all legally and geographically defined as above sea level. Sometimes I believe education and training can be a disability, as it removes the opportunity to consider that which hasn't yet been discovered or known. Memory and intelligence aren't identical things. There are savants who can calculate extraordinarily large numbers, tell you precisely what day of the week it was on any random date from centuries ago, or even see numbers as colours and shapes, yet these people couldn't tie their own shoelaces. For example, I've often noticed that pilots can be the most vehement defenders of the globe for the very reasons you've mentioned. Mostly navigation. I pronounced that wrong. That should have always been a comma before the for example. They couldn't even tie their own shoelaces, for example. Pardon me. On the stationary planar Earth, we understand that the world was originally charted in circles around the magnetic centre, Rupert, Nigra, Black Rock, Mount Meru. All the old maps shows 4 small continents surrounding it, separated by 4 rivers, and many suggest this is where the reference comes from to the 4 corners of the Earth. They meet in the centre. As all high things appear lower if distant, so too does the star virtually fixed atop a pole above this mountain, hence the name Polaris. As it drops by degrees, measured from 90 to 0, we draw circles with a compass on the charts to indicate our lines of latitude, confirm them with known landmarks, and thus we have our maps. At sea, there's no landmarks, so the stars become our guides. Thus, it's imperative we make constant adjustments to sail due east or west, and one can't just tie a rope to the rudder to remain straight. Thus, the crime of falling asleep at the wheel was so high on us, they'd usually be flogged unmercifully, a punishment rarely survived. So naturally, navigation today must compensate for circular lines drawn on flat maps if one is to take the most economical and straightest line from A to B. It would be a lot less complicated had we mapped the world on square grids in the first place, but I can assure you, the only curvature or great circle routes pilots believe they are accounting for or taking are only in 2D as your horizon keeps rising up to eye level in all directions. The apparent dip, as seen in the heads-up display, is simply altitude. Once you're in the sky, part of the horizon still rising up to eye level becomes the atmosphere itself, which is see-through, which explains why sometimes even the apparent sun or moon can seem to be below you. They're not. That's just how perspective and light in the atmosphere behaves. I made a fresh video of that last evening at sunset too, actually. You already have a link to my channel. I'm simply saying that the buoyancy factor applies to anything in air, so the plane will wish to drop without thrust or wings. A glider that stalls is a glider that falls. The wings require thrust through air to remain aloft, but in sufficient headwind it could technically hover in place. I've never flown myself, as a pilot. I've been in plenty of planes, but I've been dreaming and scheming of it for many years. My plan is to build a virtually weightless dirigible, relying on vortex energy to fly freely and silently through the air. I've put a lot of thought into it. You've not burst any bubble, my friend, apart from the fantasy that exists only in your mind. Go back to your first flight manual, as many pilots have done, and read the introduction or first chapter. All flight assumes a flat, non-rotating Earth as the very first assumption, and never corrects for a spinning spaceball, hurtling 10 times faster than a railgun projectile through space. So I'm just going to leave this episode with a short video here of Not a Professor Dave.
It is time to end a globe talking point for good.
8 inches per mile squared is not a valid way to measure Earth's curvature. 8 inches per mile squared. None of you have any idea what this means. You can't derive it. You can't calculate anything with it. You can't make a prediction with it. You can't tell me anything about this value at all.
Welcome to I Can Science That, where we do honest investigations of everyday science. Anyone who is a glober, if you're out there trying to dunk on flatties, then this video is for you. I'm going to derive the actual formula for the drop rate, the formula that NASA would actually use. So there you have it. I have now derived 4 different versions of the drop equation compare to the 8 inches per mile squared estimate. I've got the distances in miles, and all of the drop distances I have written in feet. If you're 1 mile away, the 8 inches per mile squared will give you 8 inches, and that comes out to 2/3 of a foot. So that's that. How does that compare to our actual values? Here's the actual amount of drop distance according to these different equations, and we can see that's super close. I mean, that's within tiny fractions of a distance. And so at 1 mile, it's fine. How far? Let's go 5 miles. We'll go about 5 miles. And we'll see these are the real world numbers, and here's the approximation. That's still pretty darn good. It's, 100th of a foot is how far off that is. At 10 miles, the drop is still pretty good. Look at that.
You can't calculate anything with it. If you understood math, you would immediately see that this squared on miles is totally out of place. That's because this is a parabolic approximation. This is for doing calculations with a parabola. As you can see, the Earth is not shaped like this.
But what if we're doing like a longer observation? We're going to go out further. Let's go out to 50 miles. So out at 50 miles, the actual value is there, and depending on which method you use, it's off by about a foot. Not even a foot, half a foot. From this one, based on arc length, which is my favorite, I'm off by like half a foot.
You can't calculate anything with it.
Over 50 miles, I'm going to say that's a pretty good estimate. If 50 miles away you're only off by half a foot, that's pretty good. I'll accept that.
Well, I'm sorry, friends. Those people are doing incorrect math, or lying, or both. And they are counting on the fact that you won't do any math at all to check up on them.
Let's push it now. Let's push it out to 100 miles. Surely this approximation is no good at 100 miles. Here we go. The actual value, 6,668 feet. And the estimated value, 6,667 feet. We are now off by, oh my gosh, it's over a foot. At 100 miles, it's off by a foot. That is a darn good estimate.
8 inches per mile squared is not a valid way to measure Earth's curvature.
So yeah, if somebody is telling you that estimate only holds over short distances, that estimate is shockingly good. Okay, but that's still only 100 miles. Let's go nuts. At 1,000 miles, here's our estimate based on 8 inches per mile squared. And here are our actual values depending on how we sliced it. I think you'll find that's still pretty decent.
Classic. Alrighty. So, still got a few minutes left. So he does say, thank you for the kind and respectful reply. Yes, we can keep the debate cordial, but I may give you a friendly, mischievous ribbing from time to time. I expect the same back. No problem. Don't worry. I don't hold back. And I did, actually, but anyway. The 8 inches per mile squared is indeed a curve, a parabola to be exact, y equals x squared. A slope would be an equation such as y equals 2x. If you have never graphed before, it's actually a neat tool. It takes an equation and presents it as a two-dimensional line or shape on graph paper. I'll attach some information and graphs below. I've shown you the much more complex equation for spherical curvature above. Well, yeah, you mean I just showed you 4 different ones in comparison to one another. At 600 miles per hour, we cover 1 mile every 6 seconds. A drop of 8 inches is absolutely imperceptible at that rate. Try it. Okay. Well, you can't, because we drop 9.8 meters a second squared. How can I try dropping 8 inches every 6 seconds? I guess it would seem like you're slowly wafting. So yeah, I'll give you the benefit of the doubt. You know, I've been through this 100 times in my head and thinking that, well, yeah, if you are in constant motion, what he's trying to say, I agree, is technically correct. So even though it still represents a slope, it still would be the slope you'd be on as you're constantly adjusting minute by minute or second per second. So, don't you dare. Looking at the wrong one again. Trace the length of your hand in 6 seconds and think if you'd drop that rate, if you would feel a thing. Hey? Okay. That's the amount of drop we're constantly doing. Remember, it's not a drop, it's a very shallow arc. Again, I keep coming back to speed, but we'll get there. Take a straight line representing a mile long and draw it on your whiteboard. Think about how 8 inches of that line would be. Now draw a second line that represents a mile under the first line, but arc it with that 8 inches of difference. I doubt you would even be that exact on a whiteboard with a marker. You would absolutely not see a difference in the lines. It's again imperceptible. So I'm just going to bring this one to a stop. If I can get the camera to lean forward again slightly. Yeah, I agree, it's imperceptible, and I've been saying this the whole time, because even on the flat Earth, when we're using perspective as it works, is if I draw a 1 millimeter high human being and draw a line from the top of him and the bottom from him to a point 3 meters away, that is flat Earth perspective. So they're taking flat Earth perspective and applying that to the globe and say it's imperceptible. Well, naturally enough, it is. That's why. However, as I go on in the next episode to explain why, that at speed, at 600 miles per hour, it would be 46 feet a minute. Not just 8 inches per 6 seconds, But anyway, we'll get there when we get there. I'm going to take a breather. I'll let this one upload, and I'll see if I can make the next part. This is going to take me much longer than I thought, because there's at least 100 responses there. And because I can't help myself from responding as I'm reading, it's going to take a while, but I think it's worth going through it bit by bit to show this is a pilot versus flat earther. And this is a genuine two people who genuinely believe in their position. This guy is adamant as a pilot. He lives on a spinning space ball, hurtling through space. He hasn't once addressed the orbital speed of 10 times faster than a railgun projectile, which I keep bringing up, but he keeps saying, I'm not addressing that till you address my other things. So it's like, fine. I have noticed I've missed a heck of a lot of responses because of the Facebook algorithms, so I will get back to them. I'll address them as much time as I feel is valid and relevant, but I will go through them one at a time. Whether or not I devote a lot of time and look through all the links is another thing, because some of them are tedious and boring and been done 100 times before. But this is it. I'm not backing down on this thing. I do need some amount of support if I can continue doing this on a long level standard and hopefully learn some graphics and stuff, but I don't think it's really necessary. I've got it all in here and I can talk it through, and I will use the whiteboard as required when it comes down to it if I think it's necessary. So far, not really, because it's all logic. The Earth is stationary. We're not hurtling through space. There is no void for anything to fall off any edges. We're on the stationary planar Earth fixed at the bottom of the known universe. I'm Iron Horse. Thanks for watching, and I'll see you on part 4. Cheers.